Hello and welcome back. Day 4 out of 5 of the classic week. And today I have something I really need to find out what it is. And it is from Cambridge Instruments from England. And it is a DC range box for versatile galvanometer. And it is not quite clear to me what it is. It is not a Whitestone bridge as yesterday. And I'll just have a closer look and then we try to find out. Well, here we have it. We need to remove this sticker. And there are no screws in the front. Again, it's a wooden box. So probably before 1950. Again, it says M4/S. I also have that on the other box. I don't know if I bought it from the same guy. And, oh, here. You can probably unscrew these. And then it goes out to the front. Okay, that is nice. Is that a number that is put later? So if we have a close look here, it says milliamps. And there is some sort of switch. Current ranges, milliamps for 100 efficiency. So then this is kind of a current divider. And then you can put up to 10 amps. Here you have a switch for milliamps or volts. So then you probably go to this side. And then you have here voltage ranges, voltage for 100 efficiency also. So it can also divide to 100. And then you put your voltage here. And here it said unipivot. So that I would think that's some kind of galvanometer because it can pivot unit, I think. So I found it. I had to look on the internet and Richard Radios again. He has a lot of old items and he really describes well on his website. He didn't know the age, but I found that on another website. So thank you, Richard Radio. I'm sorry, the other website I forgot. I can put the link later. I know what it is. Here, it's set already on this side. You need to put a big meter. It is the same size as this. And yeah, this is just like a pre-selection, like when you have with the multimeter, you have your meter and you have your selector. And here it was just separate. So you have a separate meter without all these things. And the output here goes to the meter, and here you make your voltage selections. So instead of having this with your selector, you would have something like this. Of course, it's a different meter, and it had also two clamps here in the front, and then it was connected like this. Ah, interesting. Yes, I found the picture also, so I can show you what it actually would have looked like. And on this website, it says that it was also again around 1930. So we're really in the 1930s, 1940s this week. That is nice. Let's have a closer look. And I really want to see the inside. And let's clean it up a bit. Okay. Well, it is not that clean. Hopefully we can just, this seems paper. It will be okay. Try to get it later. It didn't have any calibration information or anything. This also is just put by someone. It is not really. This I will keep. Let's see how we can open this, maybe with a very tiny screwdriver or two little ones. We are able to open this. I see I already missed one. That is a pity. It probably, when we Yeah, I need to find something like this, but it will stay close with 3 also. That is not a problem. Now I'm missing 2. Yeah, that opens. Okay, let's see if I put it upside down and then slowly try to, yeah, the top was this, so we open it. Wow, again, all those wire wound resistors. Look at this, how these switches look like. It looks amazing. And look, all the wire works exactly straight. They really had a lot of attention to details with these older meters. This must have cost a fortune. This area is probably the current because I see a lot of bigger wires. Yes, it is. Here we have a sort of a shunt resistor. And here also, look, there are a lot thicker wires. Yeah, so here, this is one of the shunts probably. Here also, and here you go to the lower currents. And here is the voltage area. You can have a lot thinner wires because it's probably high impedance. So you have very tiny but long resistor wires. It actually looks very, very nice inside. A piece of art, like all the old equipment. Wow. So I will take you a little bit to the cleaning process, and it is not that complicated. I'm not doing any magical things. I have here just baby wipes. It has a little bit of lotion, it says, but it is very, very little. It almost doesn't leave a residue, so it's very soft. If it doesn't hurt the baby, it probably doesn't hurt the equipment. That's what I think. And well, I have seen equipment that I try to clean now that it is absolutely no problem. Taking some of the stickers, and well, if you can see, if I use this lotion, the paint stays and the dirt goes out of the grooves. It really works, and it is indeed very soft. And because there is a very, very, very little lotion, it's really almost nothing. It gets its shine also back. And when it dries, almost no residue. Let it dry a bit. Okay, the sticker is removed. And like most of the project, it is just elbow grease. You just need to work for it, and the more time you put into it, the better is the result. Well, not always, but most of the time. I see also some screws that are almost loose. I like to tighten those a little bit. And then it looks to be they are fastened. Okay, so far for the box. You see, when it dries, it is super nice and it is not sticky, nothing. So that works very well for me. Here we have still some residue. Maybe I do a little bit deeper, but I really want to be careful. Okay, it doesn't do any harm. Yeah, no, I don't like it. I go back to my baby clothes. I think instead of leaving the glue, when I removed maybe a slightly cut paint, I think. Okay, that is the wooden box. And you can do the same with this. Just because it is soft, and I'm sure that I don't remove any of the paint also. And there was another trick that I learned from the Blaker decade boxes that someone said, because they have a special type of paint in the front. Someone said there you need to use WD-40 on a cloth, very little, but just enough to make it shine, and you don't damage the paint with it. I was surprised. I tried it, and it worked. Yeah, I will continue cleaning this. This is just doing this. Whew. But it does look a lot better already. And now I just do the trick with WD-40. Here it is. And it is just very little, so it's just a little bit on the cloth, a really little bit, and then you just put it everywhere. And then afterwards you just clean it. And it's amazing. And it doesn't damage the paint in the, yeah, as I said, in the Blakery Sisters, or the, I had the other one also, the radio. And you just need to put it everywhere. And I really only do a little bit, because it should not get greasy. It should just have his nice color back. And then you just clean it after. Okay, that looks almost new, and it's not greasy. It even doesn't leave fingers. Now I want to see if I actually using it. I will put it on the voltage. I'll put it on 10 volts, and if I use this and this, let's say if we use this one as the 500 ohm unipod. No, we have more. Yeah. here. Okay. And milliamps volts. I will use the volts. Let's put 10 volts now. First I put 1 volt. 1 volt. It is set to volts. It is to 10 volts. What will it measure? It is measuring now 1 volt. So probably because the voltage meter, now it went down. Because the voltage meter is such high impedance, it probably doesn't work. What if I just put, because this is a mega ohm or more, what if I just put 500 ohms? See what it does then, because it is probably a divider, and yeah, it expects 500 ohms here. Okay, well, I have not 500, but 470, close enough. I will put that resistor in parallel on my meter, because that is usually the load of this one. It is made for that. So now it is set to 0.1. So then it is nothing, but if I set it to, wait, 1 volt, 1 volt, then I put it to 0.2, then it's a half. If I put it to 1, it is, let's say, 100 millivolts, 50 millivolts, and now I'm set it here to 10, and then it says 10 millivolts, 20, 5, 100. So it does seem to work. So what if I put 10 volts? It's better to see. 5 volts, so it's half. 10. 2 is 5, divided by 10. Ah, cool. Well, that was nice. With the resistor, we could do sorts of measurements, and we could see the divider worked. And I just didn't get the scale immediately, but it does work. You can see it's dividing by 1, by 2, by 10, all the way up to 1,000 that we were in the millivolts. So that seemed to work. And yeah, with the current, I don't want to try that, because if I make a mistake, then I burn the resistors. So I like to keep it as it is right now. And I think we improved it, and it's nice to know how this works. This kind of a, yeah, pre-selector for this meter. Cool. I never seen this before. Oh, thank you for watching, and I hope to see you tomorrow for the 4 out of 5. So stay tuned and see you tomorrow.